because of AI, because of fast computing speeds, because of machine learning models. That is really what is making these things a reality today. I firmly believe that if the industry made this a priority, like the number one priority today, 6 months to a year from now, we would be grading cattle differently. There are bulls, there are cows that carry those genetics, and we just have to find them.
Welcome to MeatsPad. In collaboration with the American Meat Science Association, it's a platform dedicated to share breakthrough knowledge that is accessible to the global meat industry. On each episode, you'll have the opportunity to listen and learn from meat specialists and professionals about the whole meat industry. This podcast is brought to you by Ultrasource, equipment and supplies for the meat and food industry.
Hello, meat folks. Welcome back to the MeatsPad podcast. It's your happy, hungry host, Phil Bass. I'm here with my identical twin brother, Dr. Dale Woerner.
Happy and hungry, too.
That's right. Originally from Fredericksburg, Texas, now in Lubbock, Texas, or Lubbock Land, anyway, with Texas Tech University. And thanks, Dale, for joining us. Dale and I go back a couple of years, back to grad school. But
more years every year.
Yeah, well, that's the goal anyway, right?
That's right.
Let's keep adding to it.
It's all good.
So. Man, I wanted you to be here because a lot of what you and your team has been doing is extremely relevant right now in the beef industry. And so, yield to grade. For those who are less familiar with the beef yield grade, maybe tell a little bit, what is it and some history about it, because it's something we need to spend some time on, right?
Yeah, absolutely. First of all, I would like to recognize that we're working as a team.
Yeah.
Texas Tech, Dr. Blake Forker and I are working heavily at Tech. Ty Lawrence's crew at West Texas A&M. We also have Dr. Belk at CSU and Dwayne Wolf at Arizona, all a part of kind of the academic working group that NCBA has put together to work on this effort. But we're certainly not the first ones, Blake and I at Tech, to challenge the yield grade. In fact, Dr. Lawrence probably gets most of the recent credit for bringing attention, I think, to the fact that yield grade is not accurately separating what we're calling now red meat yield on an individual carcass basis. But of course, yield grade was developed originally by the works of Charlie Murphy at Texas A&M at the time. This would have been the late 1950s when he started doing the work there. I think the work was published in 1960, and then USDA adopted his equation in 1962. But back in that time, it wasn't red meat yield, it was boneless, closely trimmed retail cuts, and that's a term that I think we've all learned and kind of been committed to in discussions and descriptions for over 60 years now. But yield grade was intended to create a marketing signal, really to checks and balances of cattle. Of course, quality grade, marbling score, still very much alive and functioning very well in our system, but it's had some evolution over time and has really adapted or evolved with standards and quality, eating qualities changing, as types of cattle have changed, as age of cattle has changed, as feeding of cattle have changed, but yield grade hasn't. And even boneless, closely trimmed retail cuts, which is what yield grade in its numerical determination has tried to predict or characterize, even then was a limited portion of the carcass. We're talking about boneless, closely trimmed retail cuts from the round, loin, rib, and chuck. And even the definition of closely trimmed has changed drastically, right? I mean, a half an inch then, quarter inch, eighth inch, 10th inch, whatever the spec might be, 0 inch denuded today. So there's been a lot of things that have changed, in that 65 years of what we're dealing with the yield grade now that for whatever reason, the industry or USDA who oversees that has not evolved with or hasn't made a change. And, when I present to cattlemen's groups or industry groups to demonstrate to them maybe why yield grade has really grown out of significance, You think about 1958, 1960 Hereford and Angus, or British type cattle. A lot of us describe them as belt buckle cattle because that was the height. You know,
they just barely cover your belt buckle.
They were as wide as they were tall.
Yeah.
And a lot of that because they were fat. Light muscled and fat. So obviously the vision that Charlie Murphy and others had at that time is, hey, we're really producing the wrong type of cattle from a compositional standpoint. And I really I've seen some presenters recently show the evolution of cattle in picture form from like 1960 to 1968 or 1969, where we went from belt buckle cattle to chest high cattle, and then went in the 70s, 80s, and even some of the 90s with chin high cattle. And
they looked like racehorses in the 90s too.
Right. I mean, they were the wrong
opposite
type then too, right? But so we're really good at going from one extreme to the next. But the demonstration that I've seen in picture form was like the grand champion steer at the International Livestock Show in 1960s, this belt buckle, and then in 1968 or 69, literally the cattle grew 10 inches, hip height. And so that, I believe, was a signal or a response to the signal of Charlie Murphy putting in yield grade, in the early 1960s. So our cattlemen and cattle industry will respond quickly to a market signal. And I think that's really where we sit today is, we've lived through the yield grade era, which I think even in Charlie Murphy's eyes would have been far too long. Right, I don't think he would have ever imagined that the equation that they built on 162 head of cattle in 1960 would be living in 2026. Yeah, so it just doesn't make sense anymore. We've built, obviously, the yield grade and grading equations, based on the 4 factors of the yield grade. We even continued that with camera grading systems, coming online in the early 2000s, 2003 for yield grade. And we just kept the same 4 factors. And in fact, when the camera grading systems came online, we even eliminated a factor. We took out KPH.
Right, yeah. Yeah.
Which may have...
Remind everybody, what are the factors?
Yeah, so we've got
equation.
Fat thickness, or what we call preliminary yield grade. We've got hot carcass weight, we've got ribeye area, then we have KPH percentage, kidney, pelvic, and heart fat. KPH may have been, probably was, the most accurate factor.
Oh, really?
Well, because, KPH is pure fat. Yeah. So that contributes purely to a reduction in red meat yield. Yeah. But with camera grading systems not having the ability to assess KPH, to make them streamline or stand alone, camera grading systems, they basically just put a constant adjustment in for yield grade, and that would have been somewhere around 2.5% constant adjustment. Well, we know from today's data that KPH is actually averaging about 3.5%, on native cattle, 4.5% on dairy type or dairy influenced cattle. So we already know that we're off in that factor by an outstanding amount. Yeah. And so even bringing camera grading systems online using the same algorithm, we probably made yield grade even less accurate by removing KPH as a true measurement or a true call. So yield grade ran its course. I think it still serves today as a directional signal for boneless, closely trimmed retail cuts, or what we're calling now red meat yield. Even though it's directionally correct, we go from a yield grade 1, those cattle as a group on average are higher yielding than yield grade 5s. Mm-hmm. So our trend line's running in the right direction. If you take a look at an individual animal basis and you start looking at R square, it's amazingly low. Yeah. The relationship is really not good or not telling on an individual animal basis. So that's where we sit today, is a system that, even though it's directionally correct, doesn't give us individual animal accuracy. Mm-hmm. We've drawn a lot of attention as a working group at NCBA, all of those involved, to the inadequacy of ribeye area, right? And ribeye area is supposed to be the muscling trait. in the equation, in balance with hot carcass weight, but it's really grown out of relevance, grown out of accuracy. There's very low relationship between ribeye area alone and red meat yield. So that's really the problem child of the four factors today. We still have opportunity with KPH because we can add it back in. But ribeye area has just kind of fallen off the radar altogether. So
we cattle have gotten so much longer, you know. I
Right.
mean that muscling, it's
Right.
hard to predict from a two-dimensional surface.
A 2D image, right, or 2D measurement doesn't have relevance to length or width or depth or any of those other three dimensions, right, as we describe them in muscle. So that's really where we focused early on, is how do we replace ribeye area as a conformational dimensional measurement. And that's why you're starting to see things like 3D image, and then also, of course, you know, the CT scans that we've been working with now. But
Tell us more about that, because what you're doing is quite the undertaking. You and the team that you just mentioned. And that was great that you mentioned. It is a very big collaborative network that's working together. But this is quite the undertaking, and I'm grateful that I've been allowed to send a student to kind of help out, and they've seen kind of what's going on. But talk about the materials and methods, as we would in the animal science world, of what it is that you're doing, and then let's get into how are we going to apply that.
yeah, I mean, the reason it's such a big undertaking is because the traditional means of doing this type of work is a cut 'em and weigh 'em test.
Yep.
And when we go into a plant or a meat lab, doesn't really matter because we've done them in both places, and we try to measure the yield of an individual carcass, that means we have to have knives and scales. And disassembling or taking apart that carcass component by component, piece by piece, getting very granular and accurate measurements by weight of those carcasses takes a lot of hands, skilled hands on the cutting side for sure, and quick hands on this measuring or scale side to go with. So really what CT measurement is an X-ray. It's a type of X-ray where we're taking slice by slice measurements of the carcass. We take hundreds of slices, 2 millimeter, 4 millimeter, 8 millimeter thick, on the carcass to get compositional measure of those slices. And the way X-ray works is based on density. The term is Hounsfield unit, which is a direct measure of density on what we're calling a voxel, bivoxel basis. That's really synonymous with pixels on images. So basically it comes down to a very small subunit of that X-ray. And those subunits in most cases are a 2 millimeter cube or a 2 millimeter by 4 millimeter cube, where we have the ability with the X-ray to determine what the composition of that voxel is. And when I say that, we're characterizing muscle, fat, and bone on the basis of those density measurements. And then it becomes kind of like a Lego, experiment. Yeah. So those voxels you could think of as chips or Legos, three-dimensional boxes that are determined as muscle, fat, and bone, and then they can be reassembled, as a Lego 3D toy. Yeah. And so each component or each voxel is muscle, fat, or bone reassembled in 3D, and then collectively we can put that carcass back together and say, okay, we have X number of units of muscle, fat, and bone. Because we have density, because we have volume, then we can compute mass. So it's
and now you have three-dimensional measurements, whereas if you had to cut it and weigh it, intensive management of personnel and product and everything, you still don't have the dimension. Right. You just have the weight.
Right. Yeah, we've been really good at capturing single unit of the three dimensions over time. But now we have multiple dimensions that can go back together, which really kind of puts the data to life and makes it visual, but also makes it relevant to mass and volume. So it's really neat to look at the data. The data makes sense. Even sharing it with a lay crowd, they're like, oh, I can see what you're doing, and that makes logical sense. So communicating it and sharing it with the industry is pretty easy. And that's why I think we've had such a good success in people getting on board and saying, yes, what you're doing makes sense to us. We should move in that direction.
With an extensive range of equipment, parts, and industrial supplies, Ultrasource has been providing solutions to companies worldwide since 1883. Whether you're looking for kill floor equipment, vacuum packaging, or high-speed labeling, Ultrasource can custom tailor a solution to meet your specific goals and brand image. Choose Ultrasource for all your food packaging and processing needs.
So yeah, we're able now, compared to the yield grade equation, we have much greater clarity, much greater accuracy of what the carcasses are actually made of. Problem is these X-ray technologies are not chain speed. We talk about chain speed in our industry. That's seconds per carcass, and we still need several minutes per carcass with the CT or even the other types of X-ray to resolve that data. So we're still talking about building algorithms, building equations for something like a rapid tool, like an image, a 3D image, that can be trained using the CT data. But what the CT data really does is replace that army, that workforce that it would require to disassemble the carcass, to weigh the carcass. Because what the CT can do is really replace that cutting test. So in a handful of minutes per carcass or per side, we can replace what would normally take 30, 40, 50 people in a plant on a dedicated day or a dedicated shift. And so we can capture that data with far fewer resources, at least in the way of people, to glean that data from every carcass. So the idea is once we prove the relationship between CT and the cut 'em and weigh 'em data, then maybe we can just run a CT scanner, with a handful of people operating that to gather what we're calling gold standard compositional data that can be used to train the next instrument, whatever that might be. I keep using 3D imaging as an example. I think that shows a lot of promise, but I couldn't guarantee that someone won't come up with something better, right? That can work just as fast or maybe even more accurately than what we've seen with the 3D image. But the point now is that the CT seems to be the gold standard measurement, or is quickly proving itself to be that. So we're expecting that, in the near future, months or years from now, we'll be, co-developing technologies with CT scans and whatever's next, in hopes of replacing yield grade.
Okay.
And so that's kind of a correction I have to have with a lot of audiences, like, so you're repairing the yield grade. It's like, no, we're not repairing it.
No.
Like, we're going to replace it.
We're buying a whole new rig.
Right. and I don't know how much reference we'll continue to make to yield grade once we have taken that step forward. We're calling it red meat yield. I don't know that that's right or wrong term, but it's what's stuck at this point. And I do think we'll see, cattle or carcasses being measured in some continuous, data form, right? This is a continuum of red meat yield or continuum of edible portion or whatever we end up calling it. And we still don't know what, quote unquote, the grading system, might look like, if it'll just be a number, a percentage, or if it'll still be categorical. But something I think will evolve and change us away from what USDA currently houses as the yield grading system. And so again, this work is being done independent from USDA, but USDA is aware, right? They have representation, and we've had a lot of transparency on what we're doing and the approach that we're taking. And I don't know, truly what the plans of USDA are or what they will be in reference to this, but I kind of like the way it's going now, in the sense that they're letting the industry do the work. And then I think if we find something that works, then they potentially will come in and partner with the industry and with the work that's happening to say, okay, this is where we go next, or this might be the next.
Well, and whether they come in and say, we are now going to authorize you to say percentage such and such. It's not like you have to get permission. I mean, there's still a lot of things that happen in a packing house that it isn't by permission of the USDA, yet the value is still given back to the processor or to the producer, right? So, so just identifying black-hided cattle, now you've added a value due to that Angus influence. And so if this research leads to just finding a percentage of red meat yield, as you've coined the phrase, and now if you're hitting categories of red meat yield as a producer, plus your marbling standards that come along as a quality thing, that's the true value that's there for the end user.
Yeah, I think this is just another tool that we use to shape the cattle industry, to shape genetics, to shape production practices, specifically cattle feeding in the realm of red meat yield. So I think, you alluded to the reference of, black-hided and quality and all of those things. Ultimately, what we're trying to do is shape genetics, improve genetics, become more efficient. And I think this is yet another tool that will help us to create the most ideal product or the most ideal animal. And you brought marbling into the conversation, and I think that's one that can't be lost, right? The marbling aspect, dare I say, is still the most important, right? And should remain the most important, because for beef, eating quality is what sets beef apart. And we can't take the industry in a direction that leads us away from, its number one trait, its number one characteristic, its value determining trait, which is that eating characteristic. Because I think every time we bring up red meat yield, beef producers have this, flashback of the 90s where we made cattle too lean, and going by the way of competing protein like pork and poultry, which have just continued to be focused on lean commodity protein. And the beef industry really can't compete in that space. The beef industry is not efficient enough from a feed conversion standpoint, from a time standpoint, to just produce a commodity protein product. Beef has to produce a niche product. And I know beef is very commodity, like in our world and in the United States in particular. We eat as much beef as we do any other protein. We're battling, I suppose, with poultry on a per capita consumption basis, but it is a niche product in the sense that it's higher priced, but higher valued. And the value comes from obviously eating experience. And now we're learning more and more about the value of the nutritional aspects of it too, and how it really outcompetes other proteins for both the nutritional aspect, nutritional density, protein, vitamins, minerals, nutrients that come with. But ultimately, it's the eating experience, right? The whole, slogan, beef, it's what's for dinner, is like, this is a premium eating experience. We know we're paying more for it, but we expect more from it. And if we just go by the way of red meat yield and leave the eating characteristics behind, then it won't work. And we know that. But there is growing demand, as we all are very well aware of, hamburger, ground beef, whatever term that we're using to describe, minced meat or ground meat.
I mean, just went British there for a second.
Right. But that is becoming more and more of the consist of what we are consuming for beef, and it's half of what we consume or more. And so I guess the point is we have to remain in the quality business, especially for middle meats and ribeyes and strips and sirloins and all of those things that we eat. But we also, it's not a bad thing to produce more hindquarter. It's not a bad thing to produce more forequarter.
Hey, meat folks, it's your happy, hungry host, Phil Bass, and we're proud to be here at the 2026 American Meat Science Association Reciprocal Meat Conference in Amarillo, Texas this year, where students, scientists, and industry leaders all come together to connect, learn, and shape the future of meat science. Thank you so much to the American Meat Science Association for supporting these conversations and for your support to MeatsPad. I can't believe we're saying this out loud.
No,
but you're right. You are correct. Yeah.
And because we're in a system where, in the United States and in grain finishing cattle, we produce enough fat, right, in that we have to blend that with lean tissue. Well, of course, we're in a point where we're drought stricken across the cow-calf producing part of the country, and we've diminished our cow supply, which traditionally has provided a lot of lean trimming for hamburger. We're importing, a lot of product from across the globe into our U.S. beef production system, and so adding more lean, on the native beef supply here is certainly not a negative thing. We need that lean. We have a place for that lean in ground meat or hamburger, and so I just, there's a lot of positives that come within enhancing red meat yield, but none bigger, I don't think, though, than efficiency and just producing more lean muscle mass on the same number of cattle or fewer cattle in the future. Is a very positive thing from a natural resource standpoint, sustainability standpoint, and efficiency standpoint.
Yeah, well, and I mean, fat has definitely gained in value, but it's nowhere near what the lean material.
No, absolutely. Even with a tenfold increase in fat value, right? Yeah. From an edible sense, but
from
also
a nickel to 50 cents a pound,
right?
It's big, but it's not where we need to be.
And there has been, gained popularity not only in consuming beef fat, but also other daily use, creams,
many other
salves, and frying oils. It's incorporated itself.
Biodiesel and jet fuel.
Biodiesel,
it's
right.
all that stuff.
Yeah, socioeconomic, sociopolitical movements have really driven that. Those aren't very reliable, and sustainable for the future always. But at least there has been some gained interest, right, in using those animal fats in a variety of different ways, perhaps to be more sustainable. But the truth of the matter is producing fat is still not as sustainable.
No, it's costly. It's costly to the producer. It's costly to the packer, and so.
And I think most importantly to natural resources like water in particular. We're sitting here today at a annual meat science meeting, the RMC, in Amarillo, Texas, right? And beef production is huge here, so long as water permits.
And this place wouldn't exist without deep wells.
No, that's right. Deep wells that pull on an aquifer that spans a big portion of the Midwest, an aquifer that's dropping in water levels, and has us concerned certainly from an agricultural standpoint, but also a municipal standpoint and residential water, urban water supplies are critically low in a big part of the High Plains region where we feed a lot of cattle. And so just becoming more responsible with water by producing more lean and less fat in a more efficient fashion, right? We don't have to understand nutrition or metabolic energy costs too well to understand that fat's a lot more expensive than lean to produce. And so producing more lean, more efficiently, giving us the product that we're actually wanting to consume makes a whole lot of sense.
Well, and to focus, if we can get a premium maybe for producers who are focusing on greater lean deposition compared to fat. That was the whole idea of the yield grade. It's just that was hammer and chisel Stone Age. We used the resources that were available. CT was not, I don't even know if it was available in the 50s, but if it were, it was not widely available. And now you're able to acquire a unit, put it on a tractor trailer, take it to a packing house, and do some pretty amazing research. And I tell folks all the time, I remember when you and I were in grad school, and we were being told by our predecessors that we had it good because we had some software packages that were point and click for statistical analysis. We had fast speed internet instead of having to rely on dial-up at that moment. Well, now I have graduate students who are using artificial intelligence on a daily basis, large language models on a daily basis, and you have a CT scanner in your backyard.
Yeah,
not literally, but
well, sometimes. It's right out back for sure. But the data, evolution is really what's made this possible. To your point, X-ray technologies have been around for decades, CT for decades, but the ability for a meathead, a meat scientist, to sit down, have literally one, positioned in a trailer on the dock of a packing plant, but most importantly, to be able to decipher and utilize the data that's coming out of it because of AI, because of fast computing speeds, because of machine learning models. That is really what is making these things a reality today. It's the data processing capacity that we have now that makes this possible for the meat industry, right? It's long been used in the medical industry, but developing those models, deciphering that data is literally at the touch of your fingertips, or at the point of your fingertips.
Now we have that computing power that's available to us.
Yeah.
And so even if we could have used a CT scanner 20 years ago when you and I were in grad school, we didn't have the computing capacity to
we
be
couldn't
able to
have managed the
digest
data.
it.
No, and it wasn't just the computing capacity, but it was the algorithm, the software development, the statistical development that's gone with it. And of course, that has tracked with computing capacity. But I mean, literally, a couple of graduate students working over the last 3 or 4 years have made all of this come to real life. It's not me. We've had ideas, we've led, but we've really just employed and facilitated graduate students who could get on and learn, self-taught largely. We've had really good help at Texas Tech with a guy named Harshit Parmer, who works in our Neural Imaging Institute, sits at a CT scanner and MRI machine every day of the week, but is really a data guy, and helps to build software, build programs to decipher these data. And his mentorship with a couple of graduate students, again, have really brought all of this to life. And we just sit back and watch, kind of in awe of that happening, and just try to think of the next thing to make it move forward.
Yeah.
And it's moving.
Yeah.
The most popular question I get, again, going out and talking about this is, well, how far away are we? And it's always, well, in your crystal ball, I'm like, well, I don't own a crystal ball.
I'll have to strike that one from my list of questions for you.
Right. But it is that type of question, right?
Yeah,
because
well, people are eager.
they want to know.
Yeah.
The reality is the hardware exists, software exists. It's just going to be a matter of when the packer, when the industry is ready to make this a priority. I firmly believe that if the industry made this a priority, like the number one priority today, 6 months to a year from now, we would be grading cattle differently. So what I'm trying to say is we are equipped to do it. It's just a matter of when cattle market changes enough to allow for it, a little more money flowing through the system, a little more profit, particularly on the meat side of the business. Today there's none. So there's got to be some money in the bank to do that. So we need that climate to change somewhat. But even when we're able to change the market signal, because that's really what we're talking about doing here, is using these tools to change the market signal to reshape and redevelop cattle market. Mm-hmm. So we, meaning the meat industry, the packers, really don't have the leverage at this point in time to add a premium or a discount, for red meat yield.
No, they're not in the driver's seat at the moment.
Yeah. Discount is not a word in their vocabulary today. And that's really helped to get us into the problem we're in with cattle being overly conditioned and overly fat, because they cannot put the correcting pressure by the way of discount on cattle coming in the door. It's too competitive. They can't put a pressure when they can't get enough cattle in the door as it is. So there's really not an opportunity in this climate to make a corrective change. But I suppose there's always an opportunity for premium. If they start identifying cattle that are performing at premium and paying premium, then it doesn't always take a discount, right? No. But I suppose a lack of premium is a lost opportunity. So,
sure.
It's like choice lick spread. It's like,
well, yeah, that's exactly what I was thinking. I live more in the quality side, not the yield side, but in the quality side. And the reality is that we just really don't have many select cattle out there. we've had weeks under 10% of the grade. And just to give everybody a perspective, in the 1995 National Beef Quality Audit, it was 48% of the cattle that were graded in the United States were USDA Select. That's the bottom of our normal range. Today, it's less than 10%. And we have weeks where we're at 15% prime. That's the top end. Go back to 1995, it was 1%. And I think I was rounding up to 1% at that moment. So very drastically different situation. So now the baseline price of the overwhelming majority of cattle out there, low choice, is very easy to achieve. And like you're saying, we give premiums to prime. We don't give premiums to a low choice, but we give premiums for something that's modest and higher, moderate and higher. That's the two levels higher up in the choice grade. And then you get into the prime. We are giving premiums for that. So there's really no discounts happening right now. And to a large extent, as far as the quality side is saying, I love what you're saying, is that we don't need to necessarily focus on discounts, meaning you have using very round numbers, $3 a pound for that carcass to start with. If you achieve what's a good red meat yield right now?
Yeah, I mean, it's like 67%.
67%.
Right?
If you
Something
achieve
like that.
67%, that's your baseline price. You're still getting $3. You get up to 69%, 72%. I'm going to give you a few extra pennies a pound for that thing, and that makes a huge difference to the.
Yeah, and then it becomes an opportunity cost. You've missed out on the opportunity to get a premium
Exactly.
rather than realizing a discount. So there's some of it's mental, right? Mental, emotional positioning
you train your dog with treats, not with a rolled up newspaper, or at least that's how we do it. Dale,
Right.
are you a little different?
Well,
let's not go
plead
there.
the
Let's not
fifth
go
on
there.
that. Yeah. But I think the marbling example is a perfect synonym here, or comparison, analogy, I should say. Very plainly and clearly, our industry has put out a signal for more marbling. And certainly the Angus breed, certified Angus beef, very responsible for branded program, driving choice from just choice to categories of choice and premium. Even 20 years ago, heard very progressive cattle producers, seed stock operators saying, if you're just targeting choice, you're not targeting the right thing. You have to target branded program and even prime, right? And to your point, this was in the days of 2% prime and 20% premium, or premium choice cattle being qualified. So now, of course, we've grown leaps and bounds, but it really comes down to consumer pressure and large retailers and large food service distributors like Walmarts and Sysco's, and saying, no, we want all choice, or we want all premium choice. And if you look back at the history and the growth in marbling, that's where it came from. It came from Walmart switching to all choice.
When the big buyers get in the game.
Right. Yeah. And so what I see is an industry response, I would say in less than 20 years, right, making leaps and bounds of growth in marbling because of that signal. But what allowed for them to do that is camera grading systems that gave them individual animal marbling scores. Yep. And it wasn't just a category of choice. It was small 50, small 65, small
very precise.
90,
yep.
Right? And that allowed for the genetic progress to be made, because that went back into genetic predictions, EPDs and genomically enhanced EPDs. And so I see this red meat yield, movement coming, where we haven't given them an accurate individual animal signal of red meat yield because yield grade doesn't work. But now we're evolving into a space where every animal will have an accurate assessment of red meat yield, which is a moderately highly heritable trait. And I think we will see our genetics grow leaps and bounds quicker than maybe we could have ever imagined with this type of data on an individual animal basis, where we can put selection pressure on these traits and become improved. And so, why everybody wants to know, well, why did marbling score go up so much? Well, Angus genetics, premium programs, premium, camera grading systems. A lot of folks have the idea that, well, cameras just were easier than the human grader. Well, in some parts of the country they were, maybe they still are. But the reality is camera grading systems neutralize the human effect, right? But more importantly, gave the individual data points back. If you look at the genetic progress,
and we demonstrated that the consumers are willing to pay for
absolutely
higher quality product.
Yeah,
and it's not cheap.
That's right.
But
not cheap to produce or buy.
I mean, it's a vacuum out there right now.
Right. But if we look at the two traits that have changed the most in our industry since the inception of the camera grading systems, it's ribeye area and marbling score. Why? Because those are the two accurate measurements coming off the camera. It's 100%. So when we give genetics or the seed stock world the power, right, the data is power to them, then they can make the progress, as long as those traits are heritable. And yeah, we can look at fat thickness. Fat thickness is another good trait, right? It's actually the most predictive trait in the yield grade equation for red meat yield, but it's largely management, right? So the fat thickness serves as a litmus test for the feeder. So say I fed them too long because I got, an 8/10 or an inch or inch 4 or 5 today. We've grown 25% yield grade 4s and 5s in 2025. We're over 30% now, maybe even 34, 45% now. So there's just not a stop sign. There's really not even a yield sign in the industry today to tell them to not feed cattle fat it's just marbling. It's just a green light for marbling.
Let's remind our maybe our smaller processors out there, the farmer and rancher gets paid on weight. That's right. Okay. Once you achieve the muscle potential that you're going to get, the only way to get more weight is to put more fat on that animal. We used to say, put more fat on for marbling. Well, yes, to an extent, but that subcutaneous fat, that external fat, it actually becomes kind of a costly endeavor. And so the feeder has to make a decision on, are prices of inputs going to be low enough that we can keep putting more weight on this animal and really it's going to be fat. And so now we have some pretty darn fat cattle out there. What if the research you're doing goes and can send a signal back and says, guys, if we focus on animals that are still high quality, but we're going to put the weight on in lean instead of fat.
Yeah, doesn't that make sense?
What a win. What a freaking
At
win.
half the caloric cost, right?
Yes.
So if we can get the marbling, Phil, we can't make that point enough. If we can get the marbling in those cattle that also have the capacity to continue to put lean on instead of fat, subcutaneous or intramuscular, then we have to do that. It only makes logical sense that we would prefer for our pounds to be lean muscle with high levels of marbling. And everybody's like, oh, well, you're asking for the silver bullet. And it's like, yeah, we are. But if we never set the target, it's possible.
It's possible. Yeah.
Right?
Yep.
And it's possible with the 1%ers in the genetics, or the top, draw the line wherever you want on the tail of the test there. Like you want 1% or top 1, 2, 3, 4, 5%. Either way, we'll have to make progress with artificial insemination and genetics. Right? And spreading the genetics that do and can give us both. And there are bulls, there are cows that carry those genetics. And we just have to find them, which is easier now than it ever has been before. We have to multiply them.
I mean, we can find out if they have that potential at day one of
That's right.
life.
Or even before. Right. Right.
You're more advanced than I am.
No, they can, and I think there's
wow.
Yeah, there's a lot of fascinating things, right, in the genetic space and reproductive spaces, and they can genotype embryos unborn.
Sure. Okay.
Right,
I see.
in utero.
Yeah.
And they do.
Okay.
And the dairy industry is actively doing that. They are genotyping unborn calves, embryos, and understanding the genetic potential of those cattle, which is very reliable and accurate in a lactating, system. And in fact, they're able to actually multiply those genetics earlier, right? Skip generation intervals, but that's getting way off into the weeds and out of my comfort zone from a, genuine expertise standpoint. But we live in an era that many things are possible, and dare I say, all things are possible. And I believe that's true. I've learned enough, been around long enough to know that if someone says, is that possible, that the answer is probably yes. And even in biology. And so we live in an era where we can make very rapid advancements to, the unicorn, the 1%er, right? The prime yield grade 1.
Prime yield grade 1 is exactly what I was thinking.
But prime yield grade 1 is not the right animal. From an idealistic standpoint, we say that
Historically it was.
Right. But it's really more like a prime yield grade 3. And why do we say that? Because fat does contribute to subprimal yield. And that's one of the biggest misunderstandings, I think, and something we'll have to balance. Because even if we can quantify lean, like some level of fat, it's 2 points on a graph meeting. It's like this level of lean and corresponding level of fat equal highest red meat yield. It's not the leanest one. And that's kind of puzzling, right? Because
it is for those who think only of efficiency and not of optimization. It's not maximization, is optimization, and finding how can we optimize the value of that animal.
And that
because you can maximize it, but then you can't get them through the door, right?
Yeah. Optimization is key, and optimization is primarily driven by economics. And so the leanest animal, luckily, for what we're talking about from an eating quality standpoint, is not the most optimal animal. And it really needs some level of fat. And I keep arbitrarily saying some level because I don't know what that is, but we're going to figure it out. CT will help us figure that out. We will know the target, and just know that the target will not be a yield grade 1, even though it seems as if that has been our target. But packers know, meat cutters know that that's not the highest yielding animal. That is not the animal that puts the most pounds in the box, because we leave a lot of seam fat in cuts, and we actually leave a lot of subcutaneous fat on cuts, even if it's out of spec, right? But the optimization, the value optimization is leaving fat on cuts for the processor and the packer. So there is a gray line, in there somewhere, but it definitely is not a yield grade 1. It's probably not even yield grade 2. It's probably a 3 that makes us the most economically viable or valuable optimized carcass.
I do an exercise in my class that I demonstrate your prime yield grade 1. They don't tend to be the biggest animals,
right?
And so
they're lean
because you're running. You're not getting as much growth on that critter. They put a lot of their effort into just putting the marbling down, and they were done early, right? And so I do that compared to a choice yield grade 3 that just happens to have a few extra pounds on it. The choice yield grade 3 wins in the price scenario that I put out there. Even though we hit the unicorn animal that everybody thought in the past that we are all trying to achieve, in the end we still need to pay the bills. And that guy, although it's an ideal one on paper, it's not hitting everything. It's not paying the bills for the feeder. It's not the one that's going to be right for the packer, and who knows how it's handling, how its early life was like out in the pasture.
Red meat yield's a 3-day short course. It's not a 1-hour lecture.
Well, and then surprise part of the day, we've been kind of dancing around this, the beef on dairy mixes that are out there, and so I think it's important. We've been talking for a while, and I joked with Dale that this is going to turn into a 3-hour podcast, but because I could spend as much time as I would love to on this topic, but we should probably start thinking about landing the plane. Let's talk about, for those who are less familiar, what this whole concept of beef on dairy is, because that might sound silly to some. So,
yeah, of course, beef on dairy traditionally is an F1. First generation cross of a dairy dam or dairy type cow, which majority would be Holsteins, but some Jerseys, purebreds, and then a whole bunch of hybrids in the mix. So we got the Hojo cows and, and then we got the Hogus steers, But the idea is obviously we have a beef bull on a dairy type cow. And the variety in genetics on the cow side has changed as much as the bull side, in the sense that a lot of dairies are, traditionally in Holstein or traditionally in Jersey, one or the other. Now we see a whole lot of blending of those, genetic types for a variety of reasons.
Trying to find the ideal milk producer.
Efficiency,
right? Yeah.
butter fat, volume, all of those things. We're not dairymen, but the dairymen are as much, if not more sophisticated as, cattlemen or meat scientists. And they're far more data-driven, which is really what got us to the point where we are in our industry today, because back in 2016 and 2017, our industry was rich with cattle. Supply was not limited. Packers had the choice to refuse, accepting or procuring certain types of cattle. And a very loud signal was given by one of the largest packers in the country that we will not harvest Holstein-type steers or heifers in our packing plants anymore. And so basically we went from, a $50 day-old dairy calf to a $0 day-old calf. And the dairymen needed the pregnancies, obviously, for lactation purposes. And they couldn't afford to lose all of their money on a calf that was of no value. So in typical fashion, the dairymen are very quick to respond, and when they do, it makes a big impact because they have a lot of cattle. And I always use the analogy, we consider someone in the U.S. with 300 cattle, 400 cattle, 500 cattle or more, really big ranchers, and they're not even, if they were dairymen, they wouldn't survive.
It's one pen.
Right. Yeah. I mean,
Dairy business.
Dairy business has evolved into a 5,000, 10,000, 15,000, 20,000
in many cases,
cow herds. And so these are the largest ranchers in the United States with dairy cows, and they're still producing calves. And so back in 2016, 2017, we really started seeing a change in genetics, beef genetics going to the dairy herd in the way of AI. Of course, and AI not meaning artificial intelligence, but artificial insemination. And so we started to see the shift right then, and it was growing very rapidly. And at that point, nobody knew how much it would grow, how rapidly it would grow. There were some late adopters, but certainly by 2020, 2021, we were having a couple million, 2.5 million, 3 million of these calves. Now we're above 3 million on an annual basis of these F1 beef on dairy crosses, and they're here to stay.
That's perspective. We have a rough number, 9 million dairy cows in this country. So a third of those are having
a third of the offspring,
a crossed calf
or
right
more.
now.
Yeah. So,
wow.
which, it makes sense. It's crazy. And they've been a great research tool for the entire industry. And I'm not saying we've used them for that, but because we've desperately needed them, right, in a time of short cattle supply. When beef cow numbers shrink, dairy cow numbers stay the same because of the production systems. We're feeding them, regardless of drought, regardless of, climate and conditions. So they've been a very, very consistent in the way of number and volume cattle supply. But the best part is they've improved, genetically drastically towards beef production, which is candidly easier to do when you're using 100% artificial insemination. Unlike the beef industry that's 5% or less, artificial insemination. So the genetic movement, genetic progress, carcass data, right, has really driven that movement. And so we've seen ribeye area increase, marbling score increase. You talked about 15, 17, 18% prime. What percentage of that is dairy influenced? Probably half, maybe more. And so, we kind of leave that out conveniently when we're, native cattle producers. But without this population, we wouldn't be in the same situation relative to eating quality. The earliest concern of the beef on dairy crossbreds for the packer processor was red meat yield. Obviously, you're bringing in a deficient muscled breed in the dairy side into the equation. So the obvious first concern or question is where's the muscling going to come from? And so, of course, the bull side of the genetics was putting pressure on ribeye area. And so ribeye area...
Because it was a measurement we had.
The only.
Yeah.
Yeah, the only, at least from a straw of semen and an EPD to match it. So we grew ribeye area very successfully in that population. Problem is to the point of our previous discussion, ribeye area doesn't tell us much, if anything, about red meat yield. So continued, messaging and pressure being put on total muscling conformation. Originally, these beef on dairy crossbreds were significantly leaner than conventional cattle. Yeah. Today, they're not. They're not. Because we've overfed them. We fed them well past their optimal.
To get weight.
But
they do marble extremely well.
Oh, exceptionally well. But, I mean, in a underdeveloped calf, I mean, you can literally perform a necropsy on a hutch calf and find, 6-7% IMF in the LD.
Intramuscular fat. That's going to be
a modest moderate score.
Mid-range choice.
So these animals are born right with the potential to put marbling in. It's genetics, and so they have brought a lot of quality into our industry. They've helped subsidize, if you will, or keep us at a more constant level from a beef production standpoint. And they should be here to stay, right? Because they are far more efficient than the traditional purebred dairy calf or dairy steer coming into the industry, and they've added significant value in terms of eating quality.
Well, and for those who are less familiar with the dairy industry, they have brought profit back to these dairy producers. I teased my friends on the dairy side of things in the animal sciences, but milk is now a byproduct of the dairy industry.
Yeah.
Because they're beef farmers.
I think milk's trading between $15 and $16 a hundredweight.
That's not break even.
No.
They can't pay the bills with that.
And the calf, I'm told, adds $300 to $400 per hundredweight milk equivalent right to the cow. So we're contributing, 25% or so, or maybe even more in some cases, of the total return back on those dairies. And we've gotten to the point where they can't live without it. Yeah. In fact, I think you could even figure that the beef value is somewhat of the demise of the low milk price, because dairies are staying profitable because of beef.
They're not focusing on production.
Right. And so there's not as much pressure to make milk prices higher when you've got an offsetting beef value. But this week, and over the past month or more, day-old dairy calves, $1,850 on average.
Every time I talk to somebody about this, it goes up by about $50 to $100.
It seems like it. And the high end is well above $2,000 for a day-old fresh-born dairy calf. Well, I should say not dairy calf, but a crossbred, right? So the value is horrendously high. Yeah.
But that's the demand right now. I mean, there's the value of all beef right now is very, very high.
Paying $3,000 for a 550, 600 weight weaned calf. So it's kind of scary though to start with a nearly $2,000 investment at day old and try to get it to a $3,000, saleable 400 or 500 weight calf. Very high risk in doing that. So there's a ton of financial risk out there in this space, and the industry's managing through that. But we live in an era recently where we're at negative margin on the packer. Feeders are putting cattle in at negative break even, so they're $400 or $500
they're right on the
back.
bubble. Yeah.
And it's a risky, scary time to raise beef in our industry. And we love the high prices. We like to talk about how valuable our product is, but where are we at, from a economic sustainability standpoint? And that's for the economists to project and figure out. But the truth is we're going to have to be more efficient. Mm-hmm. I think beef on dairy and red meat yield help us do that. We're going to have to drive greater value, which means more edible portion at higher levels of marbling and quality grade. And so these types of movements in our industry are going to help keep us right in the black, I hope, and keep beef center of the plate for consumers.
We just have to remind everyone in the industry that everyone needs to be in the black.
Right.
And that's kind of that's some of the conversations we're having. I mean, you and I, we could go, we could spend an entire 3-hour dinner just talking about that subject alone.
If everybody made $200 to $500 a head, couldn't we all be happy? Right.
Yeah.
And I actually said that. I said, wouldn't it be nice if everybody just made $300 a head? And the guy I was talking to says, well, not the packer. They don't need to make $300 a head. They can make nothing, you know.
What I remind people
there's
that
division.
is that if you don't have the packer, all you have is a zoo.
That's right.
Because
Petting
that
zoo.
has to be the end use of these animals.
And most, right, understand and realize that economics have to be positive for the entire industry in all segments. But there is this, individualism or segmentation within our industry that has always existed and probably always will. And that's what helps drive the market. But something's going to have to change, right? We're going to have to become more efficient so we can be more profitable from start to finish. And hopefully the consumers continue to pay for the product.
Well, that's why I love the beef industry so much. Why I play in that area so much is just it's so dynamic. There's a lot of things going on. It's fun because you do see some of those major price jumps in one category, one segment, and then the other one's struggling, and then it kind of goes the other way, and it's just and then you bring in just environmental factors and fuel costs and everything else. It makes it a fun area to play in. So.
Risky business.
Risky business. What is it that draws us to that?
That's right.
I don't know. That's why casinos are still there. Thanks, Dale.
You bet.
Appreciate
Enjoyed it. Thanks, Phil.
At MeatsPad, we're proud to collaborate with the American Meat Science Association to help share the conversations shaping the future of meat science. The association brings together students, researchers, educators, and industry professionals to exchange knowledge, support innovation, and strengthen the next generation of leaders. Through this podcast, we help extend that mission by bringing those stories and insights directly to our audience. Learn more at meatscience.org.